Hi guys, welcome back again, and we are going to continue 5.1 quote-unquote day 3. Yesterday we talked about conjugates, and we're going to deal with something very similar, having to be related to trig expressions that contain fractions. Now I'm going to start a little bit differently. Before we continue, what I actually want to do is I want to go over a problem from your homework from last night, and it's going to be the last problem because it had tangent and secant on it, and I know sometimes you guys see that and panic a little bit. So on your last homework, this was number 3, and I think a lot of you are probably going to have some questions on this. So the problem was tangent squared theta over secant theta minus 1. And let's consider this more of like our do now for today. So just like anything else, we see a secant minus 1 on the bottom. If you found another way to do this, that is fantastic. Like I said, you can let me know. But just to keep things constant, when we see that secant minus 1, it's not squared, so it's not an identity. What I'm going to do is we are going to again multiply by the conjugate, which is what we did all day yesterday. So secant minus 1 is the bottom. The conjugate of secant minus 1 is, of course, secant plus 1. Okay? Follow the steps. Multiply by the conjugate. Leave the top as is. So tangent squared theta times secant plus 1 over the denominator. And we're just going to keep that the way it is as well in this first step. Okay? Now what's after that? We leave the top factored out again because we're going to end up looking for some sort of identity in the bottom. And in the denominator, we are going to FOIL. Secant times secant. Secant squared. That's our first. Our outer terms plus secant. Our inner terms minus secant. Our last terms, negative 1 times positive 1 is minus 1. And again, can we clean this up? Positive secant minus secant, that goes away. Let's rewrite this and see what it looks like. Tangent squared, secant plus 1 on top. On the bottom, we're left with secant squared minus 1. Okay? Now we're going to say, does anything here ring a bell? It just so happens, look for that Pythagorean identity. Okay? Secant squared minus 1 happens to be tangent squared. So we're going to rewrite the top. That's what we were looking for this whole time. We get secant theta plus 1 over our denominator, which now turned into our Pythagorean identity, tangent squared. When we have a tangent squared and a tangent squared, they cancel, and I'm just left with secant plus 1. So this was your third homework problem, and hopefully that cleared it up a little bit, following those same steps we keep talking about. Okay? From here, as always, if you didn't fill out the survey on your homework or check your homework, please stop and go do that, especially since you have one of the solutions worked out now. Example 3. So let's go back to that same note sheet from yesterday, and we are going to pick off at example 3. Now if you notice, example 3 looks a little bit different. We are no longer using conjugates. If you notice, there are 2 different fractional terms, not just one, and they're separated by addition. So it says by rewriting over a common denominator. So let's stop and talk about fractions for a second. If I asked you to add 1/5 and 2/3, you could not do it. You would have to first find a common denominator. The easiest way to find a common denominator is to multiply the 2 denominators. So 5 times 3 is 15. You always say, or maybe I'll leave it as 5 times 3. You always say to yourself, this denominator has a 3. What does it need? it needs a 5, so I'm going to multiply top and bottom by 5. This denominator has a 5, it needs to be multiplied top and bottom by 3. Once I have the common denominator, each one of these I can then proceed. So what would I do from here? I would just multiply 3 times 1, which is 3. My common denominator would be 15, plus 2 times 5 is 10, over 15. And now I can combine them, combine the numerator, and put them over my common denominator. And of course, we wouldn't leave it as 3 plus 10. We would just make it 13 over 15. Okay? Same thing we're going to do. We're going to find our common denominator. We're going to multiply anything that needs that piece to both sides. And we're going to put it over our common denominator and simplify. Maybe we'll find an identity in there. It's highly likely. So I'm going to erase this. Of course, you can go back in your video if you want to refer to it. But don't think of it any different as when we use numbers. Okay? So example 3 says simplify 1 minus sine over cosine plus cosine over 1 minus sine. Just like with fractions, the easiest common denominator is always just to multiply the two denominators that are there. Cosine times 1 minus sine. Okay? It's the easiest way to find a common denominator. So what does that mean? I'm going to rewrite this right in the middle here. 1 minus sine over cosine plus cosine over 1 minus sine. And I'm going to ask myself, my common denominator is up here. What does each piece of this need? Which part of the denominator? So if we look at our left piece, the 1 minus sine over cosine, it has a cosine, it needs a 1 minus sine in the denominator to be able to fulfill the common denominator. So, because of that, I'm going to multiply top and bottom by 1 minus sine. The right side of this, looking at the common denominator, has a 1 minus sine. What does it need? It needs a cosine. So I multiply top and bottom by cosine, just like with our normal number fractions. It looks messy, but your job is to just take it piece by piece and follow along with me. So what do we do now? Well, this will also follow some sort of pattern. So now I'm going to look at the top left here, and I'm going to multiply the numerators. It's 4 terms again, so just like with the conjugate, we're going to FOIL. First terms. 1 times 1 is 1. Outer. 1 times negative sign is negative sign. Inner. 1 times negative sign is negative sign. Last, negative sign times negative sign is plus sign squared. Okay? And then on the bottom, leave your common denominator alone. Do not touch it. Don't cancel anything. Don't FOIL it. Don't distribute it. Just leave it. And then on the right side, so we have our plus sign in the middle, right? Plus sign in the middle. Carries down. We're going to multiply cosine times cosine. It's cosine squared over my common denominator. Take it piece by piece. Okay? So in our next piece, what we are going to do is we have a common denominator now. I'm going to see what I can clean up. And since both of these fractions have our same denominator, we can then combine the numerators over that said denominator. So I'm going to create my one common denominator. On the left side, I have 1 minus sine of theta minus sine of theta again plus sine squared. So the only thing I can do here is make minus sine minus 2 sine of theta plus sine squared. And then if we go, I'm adding a cosine squared. So I'm going to add a cosine squared. Once I have my common denominator, I can put the numerator on top of it. Now what can I do from here? I said to you guys 2 days ago when we learned about our Pythagorean identities, any form of sine squared and cosine squared is always, always, always 1. So this whole piece right here will cross out and just become the number 1. It's actually wonderful. So what we're going to end up having is, if you look, 1 plus 1 is 2. And then we still have the minus 2 sine theta all over that same common denominator we haven't touched, and we've done that on purpose. Okay? And last but not least, something nice will usually happen. We see on top we have a 2 minus 2 sine theta. Both of those terms, the 2 and the 2 sine theta, have a 2 in it. Factor out the 2. We get 1 minus sine theta over my common denominator. Now hopefully at this point you're still with me, and we're going to say, okay, what is the same on top and bottom? We have a 1 minus sine theta on top and bottom. Cross them both out. And what am I left with? A 2 on top, a cosine on the bottom. Our very last step, I don't like cosine in the bottom, but I know if I move it on top, if I move that cosine up top, it's going to become 2 secant of theta. Okay? So very first step, figure out your common denominator. Multiply the two denominators that are there. Ask yourself, what does each piece of the equation need in their denominator? And then you multiply both pieces by that. Okay? Then we are going to clean things up. Combine over one denominator. So we're going to combine. So we added the two tops here to combine. And we kind of simplify things. Something will usually cancel at the second and last step. Okay? I know they're loaded problems, but there are always little tricks and identities in them that will work out nicely. What I'm going to do at this point is, so the video doesn't run too long and can't be uploaded, I'm going to stop this and start another video with our second example for today. This would be a good point after you're done watching this piece of the video to ask me any questions. Find more examples online. You can see them worked out. If you need a video or you need me to further explain something, email me and I can try to make your own video. Just please let me know. I know these are difficult. I know these are challenging. But there are so many examples of them at your disposal if you need it. Okay? Don't forget to tune into the video under this. It's going to be a you try example, but we're going to do it together, of course.